A world so small, yet it governs us all. It is quantum world. They say that it is a world beyond our imagination. But there is a law that still works in that lawless land. It is the Heisenberg Uncertainty Principle. The Heisenberg Uncertainty Principle states that you cannot exactly know the position and the momentum of an object at the same time. Well, how is this possible? When we travel in a car from point A to point B, we know our position and also the velocity, through which we'll find out the momentum. To understand this, we must know that everything in the nature behaves as a particle and a wave at the same time. Since everything behaves as a wave, everything will have a wavelength. A French physicist called de Broglie came up with an equation in which he related momentum and wavelength. We can find one using the other. To understand the Heisenberg Uncertainty Principle, let us take an analogy. Imagine you are a cop chasing a suspect in a city. Now, due to broken equipment, you have only heard the suspect's description but not his position. So, you can't catch him as he could be anywhere in the city. Or else, you have heard only his position and not his description. Either way, you can't catch him. Now, this analysis isn't exactly accurate or correct, but it somewhat relates to the Heisenberg Uncertainty Principle. Similarly, in the real world, there is an uncertainty between momentum and position of an object. To understand this, let us perform an experiment. Here, let us create a wave packet which is nothing but a combination of waves of different wavelengths. As we keep on combining waves of different wavelengths, we create a point in the waves packet with a specific wavelength. This means that we have created an object with both particle and wave nature. Here, if we were to know the exact position of the point of the specific wavelength, we would have to send in more waves, and this would create a momentum uncertainty as each of the waves will have specific wavelengths and correspond to many momenta. If we were to clear off the momentum uncertainty, then we would have to send in less waves. But this would mean that there would be a position uncertainty. And this is the Heisenberg Uncertainty Principle. Now, the Heisenberg Uncertainty Principle didn't imply in the car we were traveling because we were traveling at such a great momentum that our wave nature diminished. Hence, no wavelength and no Heisenberg Uncertainty Principle.